So this is the first time I've had it. Any other time I don't. It's much better.
Right. That's we have a yeah. But the first we have land that's yeah. Well, but yeah, great job on our. Yes, he did. Yeah. He looks familiar.
Oh, yes, 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 yes. How are you doing?
Good.
Good.
I'm thinking.
Yes. Thank you for coming.
Not really.
Check 1, 2, 3. Anything else? Check, check, mic check.
Touch loud.
Mic check. Mic check. Oh, that's better. Actually, I would use it. Thank you.
That's for the drink show. Okay. Haven't gone. Just that, right here, done also. Yes. Yeah. He does not. I told Pat, and you can go. Well, that's not fair.
And then another guy at the media contest,
He's back there. He's back there. Oh.
Okay.
Ryan, why didn't you say hello? You didn't know who I was.
Hi, I was too busy trying to figure this out.
Good deal.
Yeah.
Hi, Ryan Dominguez.
Ryan,
Good media
nice to
company.
meet you.
Yeah, I've heard of you before, so it's nice to meet you.
Yeah, pleasure, very much. When questions are being asked.
Yeah.
Will you repeat the questions for us?
Certainly, yeah, and I'm sure I could have somebody raise their hand or
That'd be
whatnot.
great. That'd be
Yeah,
great.
I think I only have one person admitted right now. Oh, a couple.
Okay. All right.
First for me.
We'll
Sure.
sure to include.
Okay.
And answer.
Yeah, certainly. I'll just keep an eye on the chat and everything.
Okay,
So
super.
yeah,
That'd be super.
just ran down here from Palm Desert. Says, guess some lines of communication crossed. Didn't know I was.
Oh, that you were
Zoom
gonna
up.
be,
I was like, yeah, I'll be attending. And they're like, no, you're setting it up. And I was like, what?
congratulations.
So,
Is Tom Sephton coming?
you know, I talked to Kerry and he said he thought so. He believed so. Yeah.
I will wait,
Mhm.
for another 5 minutes.
Okay.
One starts until Tom
Sure, sure.
gets here.
Wonderful.
All right, great.
All right. Thank you so
Pleasure to
much.
meet you.
Yeah. Let's do it. Yeah, they get a vacation on the. No, that's my daughter. You pay a supervisor. This is very fine thing to say. See you. There was on the street by themselves.
Because they go there.
I got a nose seat job, because I had a broken nose 20 years ago. So a week after Thursday, I got a nose job, get open it. Sciences. That's what I was thinking. Yeah.
Okay, we're gonna start now. I wanted to make sure Tom was here, and now that Tom's here, we're ready to start.
Hey, good, how are you doing?
Oh, yeah, oh, I love you, always, okay, let's see.
Thank you.
Well, thank you all for coming tonight. This is a day where we progress forward. We have now have the results of our feasibility study, which you will all recall that we started around January of this year, February of this year. We have been working very diligently with the team that was selected to perform the feasibility study through an RFP process. And we're delighted today to provide the results. And then importantly, to remind that this is just a milestone in our progress toward the completion of this project. And we want to discuss the components of that. As we go through this, we encourage questions. It's a small group this evening, so please don't hesitate to ask a question. If you don't understand anything, just raise your hand and stop, and we'll answer the questions as we go. So I want to introduce the folks that are going to be presenting today. And so, yeah, so let's start. Mike, if you'll introduce yourself. Yeah, I'm Mike Daniel. Oh, there you go. Can't talk to someone. So sorry. Yeah, I'm Mike Daniel with Nicklaus Engineering. I'm a hydrogeologist, and I just like to name for this project.
Hi, I'm Steve Fitzwilliam. I'm a geotechnical engineer with AECom. We help with the evaluation of the geotechnical properties and geotechnical feasibility.
I think Paul would be a good idea. We've got a small crowd for everybody. First of all, I want to recognize Supervisor Kelly is in the room with us this evening. But I think it'd be a good idea for him just to go around and everybody in the room to introduce themselves. I'm Patrick O'Dowd with the Salton Sea Authority. I'm going to pass it over to you to this stranger from the north.
Hey, good evening, everyone. Joe Shea, Assistant Secretary for Salton Sea Policy at the State of California.
This is Sabrina from Salton Sea Authority. Administrative Assistant.
Tom Sephton, President of Sephton Technology, and one of the crazy folks who was involved from day one on this project.
Ryan Kelly, ditch digger for Tom's project. Ron Spears, director, what the deal going on property owners association, and chairman of the oversight committee.
Carlene Ness, I'm President of the Bahia Del Mar Property Owners Association. Bobby Salton, and I'm a member of the Bahia Del Mar, Bahia Del Mar, Corporation, and I'm an officer. And she's so beautiful.
James Felton, just a member of the community, and I want to see it grow. Awesome.
I'm Ronnie Hewitt, and I work for the local newspaper, West Shores News, and I've been working for this project for a long time. I know,
from Bureau County Environmental Health.
I am Ryan Dominguez with Eco Media Compass.
I'm Chris Scowcroft, I'm a private citizen.
So,
Good evening, everyone. Jason Mendoza, Business Development Manager with Gafcon.
and I'm Paul Hart, and I'm with Gafcon. So with that, I'd like to turn it over to Mike, and maybe you can start us off and give us a summary. Pledge of allegiance, okay, why don't we do that? That would be wonderful.
Ready? Begin.
Of the United States of America. And to the republic for which it stands, one nation, under God, indivisible, liberty and justice for all.
Thank you, Ron, for that. Suggestion. Go ahead.
Yeah, so, for this, feasibility study, it's broken into two. Okay.
There you go.
It was broken into two parts. There was the geotechnical evaluation, which was the evaluation of the soil in and around the fingers. And then there was a hydrogeological investigation to assess water, the groundwater, and whether the water quality was suitable for use in this project. So parts of of this project included looking at DWR records indicated there was a well here in town, over, it's over there. So we used some geophysical methods to try to see if we could find the well. We also drilled a pilot borehole for the groundwater well to see, evaluate groundwater quality, whether there's no groundwater, all that kind of thing. We collected samples to assess the groundwater quality. We conducted a topographic survey so that we could get an accurate elevation survey for the whole site. And then we drilled a whole bunch of 15 soil borings that we collected soil samples to be analyzed in a lab for geotechnical properties.
And then before you go forward, we determined that there was no well. After a diligent search that the well did not exist.
Yeah,
Okay, okay, hold it.
next page.
Okay, we studied the geotechnical feasibility of different aspects for, coming back and redeveloping, this property. We'll talk more about the different options after I finish this part, but I'm mainly gonna talk about the different aspects of the geotechnical feasibility that we went into. The main things, there are three things that we looked at. Soil liquefaction, which I'll go into a little bit more. Infiltration of water into the subsurface, and then we go into slope stability for the existing slopes and proposed slopes that are in the lakes right now. So we've been working, I'm with AECOM, we've been working on the Salton Sea for a long time. So we're pretty familiar with the area. We often work with different projects to give us a good understanding of the subsurface conditions in the area. And as Mike said, that they've done a field investigation to get even a better understanding of this specific area. So the big thing that we're finding is that the subsurface is quite variable in the area. You can have clays in some areas and silts in other areas and sands in other areas. That sample.
Sorry.
Oh, and like, there's a good sample of clay right over there. I was just gonna bring it up, I don't need to see it, so. You know, it's quite variable. I mean, that's not something you probably see at the surface. You know, and we found different things with clays and silts and sands. And it makes a lot of difference on the stability of them and how they hold water and different things like that. So from the seismic soil liquefaction, which is the first thing I was talking about, that affects sands below the groundwater table. So loose sands, the way they've been deposited, especially the sands here have come down from the mountains over time and come into this valley, and that's where you get all your sands. But they come down pretty quickly, so they get deposited in a very loose environment. And with the groundwater being in the sands, which is about 10 feet below the ground surface in the area we're talking about, the loose sands and the water during a design level earthquake, being this close to the San Andreas Fault, it's about magnitude 7 earthquake. That's a pretty high shaking. And if an earthquake happens, the sand vibrates and the water kind of causes excess pore water pressure, which is the water between the grains of sand, and it will cause the sand to float on that water while the earthquake's happening. And then when the earthquake's done, it all settles back down. The water dissipates and the sand settles, and it becomes in a much denser arrangement. So you get settlement due to soil liquefaction. And the important part about that is, in order to make these lakes hold water again, we have to rebuild a closure berm right by the Salton Sea. And in that area, it's a quite sandy area. And if we get soil liquefaction, you could have up to 10 inches, calculated 10 inches of liquefaction settlement. Well, 10 inches of settlement could cause some slope stability problems on that berm. It could also cause 10 inches of settlement. You could have overtopping of the berm, which could be a problem down the road. So we've looked at different solutions, and we have come up with some different ways to remedy that. Mainly what we want to do is mitigate the liquefaction settlement by reinforcing the foundation of that closure berm by doing some over-excavation of the soil down to about 10 feet, place some geogrid in the foundation, and then when you build the berm on top of it, also put some geogrid in the berm. And the geogrid will help give soil tensile strength, and it will help reduce the settlement caused by soil liquefaction. Now, soil liquefaction is a big thing in the area of the berm, and that's where our biggest concern is. The other areas tend to be clayier or silty, and they're not prone to soil liquefaction. So we're not concerned about that in the other areas of the lake, mainly in the area of the closure berm.
I heard a question about what is a geotube? So could you explain what a geotube is?
Yeah, a geotube is kind of a type of temporary berm. We're looking at a berm made out of soil. A geotube is kind of a big plastic tube that you anchor into the soil, and it acts as the berm to keep the water on one side and not going to the other side. Yes.
So one question, about the green, species conservation habitat program. What was the soil in that area versus the soil? And then builders that allowed them to do their project without worrying about seepage. They were going to flood those areas. Well, they shouldn't, you got the same type of soil.
We have a lot of the same type of soils, but it's variable around the Salton Sea. Um, like I said, the big concern here is right where the berm is. Yeah, that's where it's kind of real sandy. It may be clayer at the other areas. Also, depends on how long ago this was done. Um, liquefaction is a relatively new issue. They didn't design for soil liquefaction before 1972 at all. It wasn't known for, so I can't speak completely for the other thing, but the big thing is that our main concern is right at the, closure berm, and it's the existing condition of the soil. We're not changing those conditions to cause liquefaction.
Joe might be able to touch on it a little bit, but I know that the site is, the difference is this is a 30-acre site and the SCH project is I built out 9,000 acres. And there are areas within the SCH that have high concentrations of clay, and then time and sequence that development so they can access those clay layers. We don't have those things. I think in the ballpark.
Yeah, great question. So certainly what we observed by and large through testing the soils at the north, and I would consider Desert Shores to be more on the northern side of the sea than what we've seen on SCH in the south, is that the south, there's a higher presence of clay, which makes it easier for us to build these gigantic mega ponds. We've also got kind of an economies of scale going for us on the southern end, where even if there are like smaller areas where the clay content isn't exactly what we want it to be, we're extracting so much soil that it's pretty easy to kind of just, blend it together and get the ideal amount that we want to line. We've actually taken out so a cubic yard, I think is roughly the size of a washing machine. So we've taken out 4 million cubic yards. So picture 4 million washing machines outside of, to build the SCH project, 9,000 acres. Yeah, so that's just the soil, that's like the meta soil, but what we've observed is that there is such a high concentration of like clay underneath that soil. So it's very minimal earthwork to get what we need to do on the south to maintain all that water.
Thinking that is a large available source of clay that we're digging out, but yes, to use some of that clay it's necessary to project. So that's one of our limiting problems too. But
yeah, that's a really good idea. Let me take that back to the team and see if there's something we can do. But these technical folks might have other things to say about it.
Yeah, we're looking at some different options for clay. Mainly, which I'll get into the next thing, is the infiltration. But the problem here, we're trying to use the clay for different means to mitigate the soil liquefaction, is the liquefiable soils are below the groundwater. And in order to mitigate it, there's a couple methods you can do, but some of them are very expensive. The main method that is really nice is you can over-exit, remove all that sand and then recompact it, but you have to do dewatering because it's below the groundwater. There's also other methods, like we're looking at a project right now that we're doing cement deep soil mixing in the foundation, but that's gonna be more expensive than our whole plan. So we're trying to not look at those kind of mitigation systems that we can. We're just trying to solve the one little problem at the closure berm of the liquefaction. We're not concerned about the liquefaction post of the funding. Yeah.
Actually, the geotechnical work of the at the berm location and saying very but when you look at all the other oil protocols from build around the Denver sort of area, many of which are deeper, solid material. So, and what you're showing in this diagram, this building can come 5 feet below the ground surface for the base of the berm. Why didn't you build another borehole and found the solid material at 25 feet down would it not be a good idea to dig down that deep and then bed the berm on so much more solid material where you have less concern about it?
It is a good idea to eliminate the liquefaction when you can, but what we're looking at here is trying to avoid having to dig down below the water table, which starts getting really expensive. So what we're trying to do is mitigate the effect of the settlement under the berm. That's why we're going down 5 feet, putting the geogrid down, and put geogrid in the berm. It will help if you get that 10 inches of sediment. The geogrid at the foundation will make it so that it's not 10 inches at the surface, and then the berm will also be able to tape or settlement if it has a geogrid in it. So it is a good way to do that, to try and get down deeper and do that, but from a feasibility level, we're looking at the fact that the cost to mitigate the liquefaction is gonna be more expensive than building the whole berm and putting the geogrid in. The depth is one, it's mainly have to go down below groundwater. Going down below groundwater either causes dewatering, or you have to use another method, like I was talking, cement soil mixing or such like that. If those are very expensive, since cementing soil mixing, what I was talking about is you're putting in kind of a grid of cement. So you're drilling boring to connected to each other, go all the way down to that 30 feet if you found part of the rock there or part of soil. You go down to that 30 feet, and fill the concrete or cement mixed with the soil, and then move over the next one. Move. And the one I'm looking at right now is a bigger area, and we're running 24 hours a day, 2 rigs for 3 months. So that's really expensive. That would end up being more expensive than the entire project. So I think the solutions you're coming up with are reasonable solutions, but we're also trying to look at it from a cost standpoint on what would be the cheaper way to go, make sure we can build this and still be safe. And that's kind of what we're looking at, is looking at mitigation of the settlement, rather than complete mitigation of the soil liquefaction.
How expensive will it be to put essentially top of the side of the building, how many, whatever we have to spend solid sort of buildings, have we use that to do that water?
That would help. However, you still have to dewater all that area, and dewatering is expensive partly because of the disposal laws. You have to test the water, and if it doesn't meet this, you have to treat the water in order to dispose of the water. Those are the different things we thought about, but we just didn't think that they would be economical for the project. That could be something else, but I think if you try to do those solutions, that they would be more expensive than the rest of the project.
Speak to your question about trucking soil from the south. That's also really expensive. Farther away it is, the more it costs to bring it up here. We're actually targeting the well site that is being English to the north of that. That'd be ideal, is there. Just north of the thing, so we're the only IID part of it, and they've just got the big stadium. We're gonna try to take it from there. And so, it's really close. Between, that's talking about lots of money. This sort of thing.
I've been really curious for about 3 or 4 years about the water quality that you're finding in the wells. And also the amount that you find coming out of the wells. Are you guys gonna discuss that later?
Yes.
Okay, thank you.
Okay, I'm gonna move on to.
Joe, did you have a comment?
Oh, I was going back to the conversation that you two were having about the dewatering process, and I was just curious from your perspective.
Sorry, I just didn't bring that to the folks out to your call, we were just talking.
Oh, great.
Thanks, Jason. I wanted to pick back up the conversation that was prompted by Tom's question regarding the dewatering process and the cost drivers for that. Just curious if the cost, were you inferring hazardous waste fees as a significant cost driver there, or is it just kind of an amalgam of a bunch of different things?
It's kind of a combination of all of them.
Okay.
There's the cost of just pulling the water out and sending it somewhere else. But there's also the cost of, impacts that are in the groundwater that you have to treat before you take it somewhere else. I don't think that it's really bad, but a lot of times you still have to treat it, means you have to hold on to it before you send it somewhere else and permit it. Yeah.
If you had a off-taker for that.
Sorry, Rick.
If you had a willing off-taker for that water within, say, quarter mile of your location, would that change the way you look at that?
Yeah, I think if you had somebody, it's just like moving the soil or moving water. If you have somebody who's interested in taking it off your hands for little to no cost, yeah, that does make a difference. But that's hard to find. Somebody's gonna take the amount of water that we're gonna try and, that we're gonna produce. I haven't done the count, but it's gonna be millions of gallons.
Put that shot on that. Wouldn't being able to put it back into the Salton Sea, normally get it forward and,
Yeah, you only need the Corps of Engineers approval to put the water back in the Salton Sea, but they're still gonna have the department of cleaning up that water before it goes into the Salton Sea. Yeah, I've done a project before. I was working on the Tijuana River, and we were not allowed to put tap water into the Tijuana River. There's always something with permits, stuff like that, dealing with water. Okay, I think I might answer a few other questions that you guys may have, or maybe some other questions when I talk about infiltration. Because one of the big things with infiltration is that like I said before, the ground is quite variable in the subsurface. There are some clays and there are some silts, but there's also some sands in the other areas. Other areas as well. Apparently I can't mind it. Okay. So. Okay, so the infiltration is variable ground, and if you get sand pockets or sand layers, and you try and fill the ponds back up with water, you could end up losing a lot of water. What we did, some permeability tests for the ground, they're called perk tests, where in the ponds, we drill some holes, then you put drill a hole down in the bottom, down below the bottom of where your bottom of the pond is going to be. And then you add water into the pond and check how long it takes the water to infiltrate. Based on those tests and the counts we did, you could look at losing 5 to 10 inches of water per day. If you fill the ponds up, then you let them sit there, you lose 5 to 10 inches of water down every day. And that would become quite expensive after a while. So one of the things that we looked at is different things like liner. So the clay we talked about, or using an HDPE liner. So we talked about both those things. To try and reduce the amount of water loss due to infiltration. If you used a clay liner, you would lose about 1 inch, or I'm sorry. I have to look at my numbers, but half an inch of water per day as opposed to 5 to 10 inches before. And if you did, a HDPE plastic liner, you would, pretty much stop all the infiltration. So, and if we did it in, HDPE liner, that would be buried down about 1.5 to 2 feet below the ground surface, so you never see it. Just so you know what it is. So the infiltration, we think it's gonna be impractical to fill the ponds as they are to retain water without doing some kind of liner. So we'll talk a little bit more about, when we go to Mike, we'll go through the options, we'll talk more about the liner and different things we did look at. But infiltration was a big issue. So we think we have solutions to solve that. And then the last geotechnical issue, which is actually the simplest one, would be the seismic slope stability of the existing slope and the proposed slopes for the lakes. We think shallowing up the lakes a little bit would be a good idea, both from an infiltration standpoint and also to stabilize the slopes. But some of the slopes out there right now, if we don't do stabilization, have some instability in case of seismic event, like I was talking before with magnitude 7 earthquake. And if we get that magnitude 7 earthquake, most likely it'll be minor sloughing or pop outs of the slope. It's not going to be major rotational slides. It's not that you do have different types of material, and it has to fail through all the different types of material. It's not like you have a landslide with a big clay seam that has already been marginalized from movement over the past in geologic time. We've looked at the slope stability. We think some of the solutions we're going to come up with and options that we're going to give help protect the slope stability a little bit more, but even if we don't protect them, there are minor pop outs and stuff like that. So we think that's in good shape. And as kind of alluded to, that we would maybe shallow up not a lot, but shallow up the lakes a little bit and flatten the slopes a little bit. Yes.
What's a pop out?
Well, there's kind of several different types of landslides. There's your standard rotational landslide, which is a huge, well, not huge, but a big landslide. Could be small, could be big, but it's when a lot of times, like at beaches and stuff, you get erosion at the toe of the slope, and then you get a slide that comes down because you lose the resistance to the sliding force. Pop outs are kind of a similar thing, but they're smaller because the ground is variable, so you're not going to get a continuous slide. You're going to get it gets weak in one spot, and because the earthquake adds force to it, then you have a small little section that slides. So they might be the size of, they might move a couple cars, but it's not as big as a house. That's what I mean by a pop out. And they would be on the slope itself and not really go beyond the slope. It would just be on the slope, maybe for 20 feet beyond the edge of the slope. It's not going to go 300 feet back.
I want to make a comment on that.
Yeah.
When we had the earthquake in Westmoreland years back, the buildings all collapsed and stuff. Okay, when we had the earthquake. We had the earthquake down in Westmoreland and stuff. And I had water splashing out of my swimming pool. Water was washing up from the sea up on the First Street and stuff like that. But yeah, I felt my house doing that, but nothing slid, nothing moved. So I was no damage, so I don't.
Well, your house is on a flat section. I'll answer this when I get to it. Your house is on a flat area, so it doesn't have the slope problem. The slope problem will be more where the lakes are themselves. or other places like that.
Especially if steepens, you know, the shore goes into the lakes, it steepens, that's that part. Like where the bottom of the shoreline and the bottom of the lake is, the steepest.
Yeah, it reduces the resisting force. So that's the slope stability issue with the earthquake. But the other stuff with the earthquake, you know, your house, Southern California houses tend to be wood frame houses. Wood frame houses actually have enough tensile strength and elasticity that they do fairly well in earthquakes. As opposed, we have the same size earthquakes here in California that they do in Turkey. Well, Turkey is a big problem because the houses are made out of unreinforced concrete, and so there's no tensile strength. So it's a lot different. You might have had pipes break, or you might have had different things like that happen where it's rigid, but the house itself is actually, single family homes are actually fairly resistant to earthquakes.
Bobby, one of very few people who can claim to have been here since those channels were built. And so you have a perspective that a lot of people can't match. And so my question for you is, your house survived that Westmoreland quake, which was a big one way back when. Did you see any damage or slippage to the slope and sides of the channels when that quake happened?
Not that any of my neighbors or anybody saw or complained about or said anything about, no. I've got walls at the bottom of my property, and I didn't have any problem. But like I said, none of my neighbors or anything said anything about seeing an injury, other than, you know, the water coming up on the street across from Arlene's and stuff from the sea, and the water was splashing out of my above ground swimming pool, but that was it.
And that's probably just quite typical. The thing that we're concerned with, we said most of these slopes are in pretty good shape. We just wanted to check a few and maybe stabilize them a little bit. Nothing major on the slope stability. We just wanted to bring it up as one of the issues we looked at.
Before you put the liner down, are you gonna have to fill the erosion sites that are on the slopes themselves? Are they gonna have to be filled in, any of the major erosion sites?
Yeah, what we would do in that instance, if we put in a liner, we'd kind of flatten out the bottom and the side slope to make it so either a clay liner or HDPE liner would be continuous and smooth, so you don't have problems with it. And if we needed to, you know, this is the feasibility level, but if we needed to during the final design, you know, we would look at the water coming in and how do you make sure that the water coming in doesn't erode in the future. So that's still something to think about.
Really quickly. Question from online. HDPE liner, how long will it last before it needs to be replaced?
It should, if it's buried like it is, it should last indefinitely. HDPE liners is what they use in landfills. They just put them down once, they fill the landfill up, they never replace them.
My concern is, like my lot, the one from 190 feet out in private property. And a lot of that has been eroded. How are you going to determine private property to what you're building as far as the water source?
Carlene, you've raised an excellent question. And that is a real challenge for the project because we need site control in order to do the work that's necessary. And that requires the consent or other applicant. the 241 parcels. I think the intention is to handle that project, handle that with a temporary easement that would allow for the performance of the work through an eminent domain. And that would be probably the easiest and the only way that we could achieve this result. Because you know that when we were seeking the consent of 15 property owners to do the testing that we did, that took months just to get 15 done. And thanks to you and the other residents here in Delta Shores, we were able to achieve that result. So that is a major issue that we're going to need to work on in the future in order to achieve the result.
I think that that's something that we have to work on in the present, not the future. Because if we don't have that problem addressed, then there's no way the project can move forward. So what we have observed in the recorded map is there's a 35-foot easement on the back of each lot in the keys. And then there's a 50-foot lot that runs down the middle of the keys. The projects that we have looked at, for all intents and purposes, stay within either the individual center line lot or the lot and the easements. So we have been talking to the county, talking to others to figure out what's the most expedient way we can get access to that and with as little disruption to the community to implement a project of this type. But it is daunting because there's a bias against eminent domain taking, even if it's for addressing an emergent situation like this. But I think it's something we can get a project designed, but we can't get it built if we can't get on the property.
Okay, so back in the 1959,
I can see the slide you're on.
we're on slide 8.
Slide.
So the Department of Water Resources has records of a well here in town. And it had coordinates where the well is supposed to be. And so we use geophysical methods to try to find that well. Pardon me?
These guys stuck in a hole.
Well, this. Yeah. Good place to keep it cool, man. So, we couldn't find it. I don't believe it's there anymore either. It was abandoned a long time ago. Probably because the water quality is not too great for drinking water. It's slightly saline, which makes it what's called brackish water. It's not salt water, it's not fresh water. It's kind of in between quality of water. So it would work for what we're trying to do here. But it may, as Tom earlier pointed out, it may need some blending with salt seawater to keep plants and stuff from going into the liner, because that'll screw up the liner quicker than anything going. So there's a couple of things about the groundwater. Number one, the water that you see in the lakes is actually what's called a perch layer. So there's a clay layer down there, and then the water that comes in from stormwater and stuff sits on top of that clay layer, and that's why it hasn't ever gone away. It's just because it's a perch layer. It's very thin. It's a very thin layer of water, probably not more than 1 or 2 feet thick. And it doesn't go all the way around where the Finger Lakes are. I think that's the northwest corner. They were up there and they didn't encounter the groundwater, the first water, over by the dam and all that. It's all well, where the dam would go, the burn would go. It's all perched there. And then the second thing is the actual groundwater aquifer here is around 100 feet, but it's what's called a confined aquifer. And that's where, you have clay, where the top of the aquifer is, you get like a clay layer on top of it, so it can't come up. And it creates a slightly, as the water moves in, it creates a slightly pressure water system, and so when we drill through it, we hit water at 100 feet, well, the water in that well rose up to 25 feet just because of the pressure in the aquifer itself. So, the good things about it is, number one, there's no contamination in the groundwater or any of the soil samples that you guys, so you guys don't have to worry about environmental concerns. And there's plenty of water. Make no mistake about it. Plenty of water to do this, except for the bird watching. But and we won't have any competition for the water because nobody else is going to want to dig the water up potable. You can't drink it. You're not going to have a bunch of people trying to put in their water, drinking water wells when the person needs anything. So, and any wells. Running wells really close by. I think the next little town down, Salton. I think there's a few down there, that's several miles away, so there's some up to the north too. So anything you hear will be interfering with them, or they would be interfering with you. So yes, sir. You punish the runoff.
Is that water replenished by runoff from the hills, from the mountains?
Yeah, typically it's snowpack and stormwater, yeah. Yeah, then it comes from like north. Yes, sir.
How deep is that aquifer that's below the layer of the clay?
Well, we drilled down to 300 feet, so I know it's at least 300 feet.
Really? So you got 200 feet of.
200 feet of water bearing
Yeah.
aquifer. So like I said, there's plenty of water in it. And, if I were to design the well, I would recommend it, down 400 feet, so you got water.
The water hot at all?
No. No. And so we came to this project, primarily the option that we looked at was to build a berm, dig a well, build a lake with water. As part of the feasibility study, we also considered some other options just to, in case one of them doesn't work. One option, what we call option 2, that we had 2 alternatives to do a clay liner or the HDPE liner, and that's just lining all of the lakes as they are right now, building the berm, building the well, and pulling it up. Alternative 3 also has 2, but that has we reduced the size of the water features where it would just be main channel, and then you backfill all the other channels. It's just an option. Believe me, it's just things we consider, but not in the end of all. And then the 4th, that one, the water feature also would have had either a clay liner or the HDPE liner, and then the 4th option is just backfill it, take the park out of it.
Mike, can I reflect a little bit? I guess there was a question earlier on Zoom. I'm gonna hand the mic over to Ryan.
Okay.
Yeah, sorry, I just saw it. Salton City Community Services District owns a center lot easement. Have they been consulted and supported? Or supported?
Yes, they have been consulted and they are supportive of the project.
And I think the association wanted. Launched by Okay, so we went through and did the evaluation and the original alternative, as Steve explained, you can get 5 to 10 inches of infiltration, and it would have taken 5 wells pumping in 1,000 gallons a minute every hour of every day just to keep the wells full. And that's not what you back. And so that alternative, you can't do it. It costs too much. And operation and maintenance, alternative 1. Alternative 2 would include the construction of the soil berm to begin with, installation of a well over. Anyway, when we drilled the test point, and then you would have to pipe the water from there after you've installed the liner. There's a number of things that have to be done first. We'll have to go through and clean out the bottoms. You have to consider the fact that the soil at the bottom right now is a little soft, so we've got to be something to mitigate the soil so that you have heavy equipment down there to install the liners. Paul's already spoken to the access issues. So just when we did the cost estimate, we did not consider biological considerations, and we didn't consider the soft soil. We didn't consider a number of things. We're just trying to figure out if any of this is feasible to even try. Before we get into that, all of that will be addressed in the design part. Based on what we came up with the liners, the one with the clay liner probably cost about almost $11 million. The HTP liner would be 22, almost $23 million. Ultimately, where you go?
Could you address that you have not done any testing yet on the borrow site to determine if there is sufficient clay adjacent to the property to perform the clay liner, which is another cost consideration? You want to talk a little bit about that?
And tell us if clay had to be borrowed from a place where there is plenty, like CH area, and you had to truck it north, 35 miles or so, how much would that add to the cost of option 2A?
Looking at different things, and I'm just going to talk about it from my experience. If you move stuff from the borrow source that we're looking at, and that clay works out, it would probably be $10 a yard to move it. If you have to move it from quite a ways south, like they do in Los Angeles all the time, because there's no place or there's no soil sources at all, instead of being $10 a yard, it's like $35 a yard. So it more than triples your cost of getting material into a clay. So that's one of the reasons, the numbers he gave were for a clay liner, if it's reasonable, but that's why we also looked at an HDPE liner.
Yeah, that would be. Just transportation.
I think it's also important to point out that the assumptions we made with respect to the local availability of clay has not been tested. We don't know whether or not the material would be on that site. So the values that you will hear, the costs that you will see, assumes that there is sufficient clay on that site, which we don't know the answer to that at this time.
ID. Oh, that part. That's right.
Yeah, well, that would have to be negotiated as well.
Before this meeting,
Supervisor Kelly asked nice.
But before this meeting, we met with the general manager of IID and we explained our request. And our request has been provided in writing for their consideration. But there's obviously, as Patrick mentioned, we don't know if there is sufficient clay in that location. So that investigation is continuing.
Yeah, most of what we did here, we made the assumption that it'll be similar to what we found around the Finger Lakes over there, since it's not that far. It'll probably be pretty similar, so. Then option 3, which you guys have already said you don't like, is partially backfilling, reducing the size of the water feature. That would reduce the cost to, somewhere around $13 million for the clay liner, and probably about the same, a little bit more for the HDPE liner. And then, of course, the fourth option is just the deck fill it and make it apart. You probably don't go like that, so that. Oh, yeah, the backfill it, that'd be about $8 million. That's supposed to just move the soil. And you'd have to build one of the big things that we noticed here was that at the very southern Finger Lake, at the west end, it's got that wash that washes into it. There's been a lot of deposition at the west end of that Finger Lake from all the soil that's been washed in from that little wash there. So you'd have to mitigate that. Install some kind of stormwater conveyance system so that when the road, what you did in there, so that it would flow out to the Salton Sea. So,
Alternative 4, essentially fill in everything.
Correct.
It has a annual maintenance budget of 500 in the estimates. It has no water source whatsoever. So what kind of park do you get with no water source and maintenance budget that's, I'm sure, a lot less than what the Imperial County is spending to maintain the little soccer park in Desert Shores already? How is that a park rather than fill it in and walk away?
So what we did, is we said if we were strictly going to mitigate what happened here, baseline mitigate, that's kind of what that program represents. So everything from build a berm, drill a well, fill a hole, to strict mitigation is kind of the spectrum that we wanted to kind of understand. And so that's kind of the work that Nicklaus did, is kind of looked at all the different options. So the fact that it doesn't have the landscaping and the O&M associated with it is simply reflective of the fact that it's just addressing the condition on the ground and doesn't layer in any type of aesthetics that would have to be considered as part of whatever collectively is decided is the appropriate strategy for fixing this problem with the resources that we can identify.
I mean, there is a substantial budget for creating the park, and landscaping, the building, sidewalks, and whatever you want to put in there. But to make the park, how do you do that? I mean, the water is so good, so you got to design it. I mean, it's all a design aspect of it. Because, you're going to use groundwater. It's brackish. You have to have water that are, plants that are salt tolerant. things like that. So, you know,
We have that water. But grows very well. All over the water, it was so good. I think the right spot, all over the place. How do you do the average spot? That's
Before we get into real discussion on the alternative, I'd like to take the opportunity to thank both Paul, Unite, Louis Gordell, and of course, Ryan Kelly here, for all the work you've done on the project. You've worked hard, you actually come to some answers that we need to deal with, and you've done it in a professional manner. I appreciate that, giving us all the pros and cons. And, I'd like to personally thank Supervisor Kelly, because he's been working diligently on this for many, many years, going back to the memorandum of understanding with the California Natural Resources, which was an eight-month project to get that approved, and then working to get it into the SSMP as a project when originally it was just kind of laughed at. And eventually we got it into the actual 10-year plan. And through Supervisor Kelly, Mr. O'Dowd, Executive Director O'Dowd, we made a lot of strides in that, and I want to thank both of them very much for the hard work they did. And I also want to just bring up the idea that I was listening to the last Salton Sea Authority meeting, and one of the concerns is that the state is going to put up a conservancy. And I think that's going to be an expensive project, and I think that's going to be a division between the Salton Sea Authority and the Conservancy for available funds. I know it's not supposed to be, but money's money. So I would like to see, I think it would be in the best interests of the Salton Sea Authority to have a project, in the stages that they can use that as a kudos to completing a project or working on a project in relationship to the Salton Sea Conservancy. And now I'd like to ask Tom Sephton if he would. He has an alternative that he's proposed, and I'd like you gentlemen to listen to that alternative. We did hear part of it, a little bit of it, but Tom's more technical than most of us. So if we can, if Tom's available, we'd like to discuss that alternative too. Okay?
There's written version.
I've shared what I have. I spent $100 to make the 12 copies. I should have made 14. If anybody doesn't want their copy, I'd like to, share it. See it.
Here, take mine. I can get one.
Yeah,
It's available online.
yeah.
Where do you get it online?
It's on my website and so this concept takes from the really excellent work that has been done on this, and I just want to say I want to thank the Salton Sea Authority for the leadership in getting the grant with Bureau of Reclamation that got us to where we are today. I want to thank both Salton Sea Authority and Gafcon for vision and making this happen. and getting us to a point where we are today. I want to thank Nicklaus Engineering, like Daniel. I want to thank AECom for the very thorough, well-reported, well-documented report that they've shared with us today, and that is, and for those who asked, maybe you can get copies of it, shared copies with some of the oversight committee here. And we've gone through it, and we appreciate the hard and good work that you folks have done. And so this concept takes off of the work that you've done, and follows on a couple of issues. So on the side of just getting permission and right away to do the project at all, which we've talked about, and we know it's hard, and we tried back in 2018 to contact every one of the land owners for 244 lots. We heard that from several, but not anywhere close to a majority, not even close. So there is concern about getting permission to do major earthwork on all of these lots. So we've been thinking about a way to do a project where you could do the necessary work to make this work, where you could provide seepage barrier that does not require major intrusion on a lot of private property. And the other thing that we looked at that comes straight from the excellent work that you've done is all the geotechnical boreholes, 15 of them that you drilled all around the entire lakes. And when you look at the data that you've got, you see that typically as you get to about 25 to 30 feet below the street elevation, you get to pretty solid soil. You get to fine-grained silt and even fat clay at that depth. That kind of soil holds water pretty well. We know from our own experience and from the work that you've done that higher up, you've got very sandy soils. And what, the fingers were built on top of berms that were just part of the Salton Sea 60, 70 years ago. And then they dredged up materials and built up those berms in the sea itself. And then in order to be able to build houses on them, somebody laid about 3 feet worth of dirt and rock and solid fill material so you could build houses on top of the soft material that the berms were built out of. The soft material under the 3 feet and down to the 25 to 35 feet leaks like a sieve. We know it, you documented it, we did too, we agree. That's a problem. You cannot just keep pumping water in that and let it leak down. So we looked at, is there a way to do a seepage barrier that does not have to involve major earthwork on 244 private lots? And we think there is, because when you look for a public right-of-way, one of the public right-of-ways, they are the roadways. And we have Acapulco Lane, Thomas Avenue, and Capri going 80% of the way around the 5 acres. And that's a county right-of-way, the roads themselves. And they've got a little bit of easement just on either side of the road. So we looked at, could you use those county roadways to install your seepage system? And we think that that's possible. And there is a very well known technology that is called sheet piles, generally steel. When you have corrosion issues like you might hear, because we have salt water down below, you can get it in galvanized steel, you can even get it in stainless steel at the price. So we did look at the galvanized steel option as a cost. And if you can go just on the inside or outside of the roadways relative to the 5 fingers themselves and install a one of the common lengths for the things that make up a sheet pile. And if you, a few pages into what I handed out, you can see what it looks like. You can drive that down into the soil. It might be smart to dig through that first 3 feet of rock, and it's pretty tough, and then get down to the sand and clay that's down below that. But you can drive sheet piles down 40, even 50 feet down into that soil. And if you do that in a continuous, essentially a continuous bathtub, continuous curve, all the way around the 5 fingers, down into the more solid soil, the fat clay and the fine sediment that has low permeability, that does not leak like a sieve, you essentially create, think of it as just a big bucket, a wall of a bucket, and the existing bottom being pretty solid material will hold the water. As you pointed out, we have perched water in the bottom of the channels, right? It rained quite a lot a few weekends ago, and we got about 3 feet, 2 to 3 feet of water up in the channels that we didn't have before the rain. It's now a couple of weeks later, it's still there. It's going down very slowly with evaporation, and we measured this at the request of Gafcon back about 1.5 years ago, and the measurement was that the water in those channels, that perched water that you talked about, that we lose that when it doesn't rain at essentially the expected rate of evaporation loss, meaning the seepage loss of that perched water is very low. So if you were to create a ring of steel around all 5 channels using the roadways as access, as a right-of-way, you would be able to essentially contain the water that you pump out of the well within the 5 channels. Now, will it seep between the channels? Of course it will. And that's fine, because the houses were built on something that, on top of an area that was saturated with salt and seawater, back when it was originally built in the late 50s or 60s. So it is an option. And if you look at typical pricing that I've been able to find, and it isn't, there's definitely more information we can look into, but this steel sheet pile is used. It's used in Orange County, it's used in Huntington Beach, it's used all over California and all over the world as a way to line channels, as a way to protect harbors and shorelines from seawater encroachment. It's a very commonly used technology. And when you look at the costs of doing that based on a cost per linear foot to put down steel, galvanized steel sheet pile 44 feet down into the ground, well below the point where you have the highest layer of solid material that will hold water, you get a cost of a little over $2 million, which if you add that to the alternative 1 cost, you get a total project cost of about $5.7 to $5.8 million, which is a lot of money, but not crazy. So I just want you folks to think about that and consider whether that might be an option, because that would eliminate the problem of getting permission from all the many owners of all these lots, many of whom bought the land, 50 years ago, and it's now owned by a trust or some descendants, and it's really hard to find. So, and we tried that, and it was hard. And you tried it, and it was hard. Okay, so it's a way to avoid that problem, and it's a way to, we believe, do this project successfully and sustainably at a reasonable price tag that might actually be possible to achieve. So if you have, do read what I wrote up, and I did the budget analysis based on your way of doing a budget, and I just took out the lines for major earth fill, and I put in lines for installing sheet pile. It's about little over 7,000 linear feet to go all the way around the five fingers using the roadways. And so do take a look at it. And the one part where the roads don't go, there's 3 lot owners, right? And there's one private owner on the south side who's not easy to get to, but one of my option 5B actually goes right around his property. So you wouldn't have to go through it. Option 5A does go through it, option 5B goes around it. The middle of where the berm needs to go, and I would suggest considering the sheet pile right across the berm, build the berm, put the sheet pile right down the middle of the berm as a barrier. If you look at the Salton Sea Authority's perimeter lake concept, look at the diagrams that Tetra Tech did. They proposed to have sheet pile down the middle of those dams that were going to go and they yet go all the way around the lake. It's a viable way to consider doing it. And then the other lot owner is the Ecomedia owners right here. And they have been behind this project for 9 years now, I think. So I would suggest just giving it a thought experiment, at least, if you don't mind.
Yeah, I mean, we're always, we welcome any suggestions you guys may have. You have explained that.
Yeah, we didn't look at that at all because it would be going outside the property, like you said, going into the streets. Sheet piles are used all the time in San Diego. They're used, and in fact, my company used sheet piles for the National City Marine Terminal expansion, where they put sheet piles in to act as a cofferdam. And there are some other options as well beyond sheet piles. That would have to be something we could look into more, but we have to talk to Salton Sea Authority and see about that. Yeah. So feasibility wise, it's very feasible. It's gonna be the cost and getting the politics behind being in the street, but from an engineering standpoint, yes, that's feasible.
I would suggest doing it not in the middle of the street, but on either the outside or inside edge of the street. If you do that, the things that are in the way are about 10 mailboxes that would have to come out, go back in. And sewer and water pipes to about 8 or 10 houses that would have to be temporarily cut out, put back in again after sheet pile is installed. And the way I set it up is to dig a trench about 5 foot down, hammer the sheet pile down to 44 feet below surface, and have about 5 feet of open space above it, so you can reinstall the sewer and water pipes out to the houses, and then bring the elevation up to a foot or two below that 5 foot below street level.
It is interesting. One of the things, it sounds like you've already kind of done a lot of the study, but figure out the 35 feet bit down is where that clay layer is, kind of holding the perch water.
I took a look at the turnover, so take a look at the, it's on the second page, what I can do, and I just took the turnover. No worries, thanks so much.
I took your numbers and I just summarized it on the first, figure 1, second page. And it looks like it's basically, there's one that maybe you hit some clay at 15 feet and you hit some more a little further down, but typically between 25 and 30 feet down, you're hitting solid material. And if we push sheet pile, say 44 feet down, you've got an additional 15 or 20 feet of safety margin.
Yeah, that's reasonable, things to look at, and we'll have to talk about it. One of the other things, actually, as you were bringing up sheet piles, I also thought of what they use more East Coast, but it is used in other places, is kind of a clay cutoff wall. Instead of the sheet piles, that could be also something to put in. That way, when you go back and put the water line and the sewer line in, that doesn't disturb that, but that would be more design in. But that's a good one.
And there's not that many houses that have those water connections right now, so there are various ways to get them.
Well, that's also.
I didn't quite hear that.
If you use regular carbon steel, it will. That's why I've priced it out with galvanized, which would last longer and better. Additionally, even with regular carbon steel, one of the benefits of putting steel underground is and well underground, there's no access to oxygen. So, for example, when cast iron pipe was first invented 300 years ago, it was installed in the gardens of the Palace of Versailles. That was the first known installation of carbon steel pipe. 300 years later, a lot of that pipe is still functional. So steel underground, where it doesn't have oxygen getting to it, lasts for hundreds of years, and we have the experience of that.
So first, I want to say thanks, Tom, because that's the whole purpose of us being here is to explore where we go from here. And it's certainly an intriguing option, and we'll have to see what the cost of implementing it really looks like. One of the things that we talked about earlier that would also have to be addressed is the water quality and the different vegetation that might be growing and the maintenance and cost of maintaining this project over time, how that's going to get addressed. But I think that we're at a point where we need to come up with a viable, reasonable, achievable solution. And it certainly sounds technically achievable to me. I just don't know when the cost will come out on the construction and on the inside. We can figure that out probably pretty quickly.
Can I ask you a question, Roger, about I don't need that, about the procedures that you're gonna follow between now and when the grant is supposed to end in December? Are you, in order to re-up the grant and keep it viable? I heard that was going to be, you guys are going to Sacramento to present something?
So we have been in discussions with the Bureau. It's not Sacramento, thankfully.
Okay, fine.
No, Sacramento is our friend, but we are
local
working
representative-
with the Bureau in this particular grant.
Right,
And we have had conversations with them about how these funds can be used. And to create a fully engineered shovel-ready project that's going to take some more money. So the conversation we've had with the Bureau is, can we use the remainder of the grant to develop a fully engineered shovel-ready project that we can find money for? And that's what we're moving toward.
okay.
Executive Director, can you tell us who the contact person, Patrick? Can you tell us who the person of contact is for the BOR now? So do we have somebody that we're, locally between the Salton Sea Authority and Bureau of Reclamation, the person of actual contact? That's locally.
So that's still to some degree in a state of flux. They still don't have a new commissioner. There is a gentleman that I deal with out of Temecula, but he has not been deeply involved in the conversation. He is involved in the advancement of this request, but we do have a grant specialist that we've been working with since inception, and it's the same person we've been working with. But it's not really someone that is Leslie Walker or Leslie, whatever her other last name is. She has a couple last names. But I can certainly, provide whatever information I have on the hero representative. But I think so what we're doing right now is well, the government is kind of shut down, so they're not doing a lot. But we do have a request into them. We've given them all the information they need to process an amendment that would allow for those funds to be used in the manner that I described. And what we evaluated is, a broad spectrum of possible project variations that these funds could be used for, and everything that we've talked about today, I think is well in line with what we can use the funds for. So I think it's really super critical to have a shovel-ready project. We're going to be looking for money, and we have a shovel-ready project, and we know how much it costs, and it's not ridiculous. I think it goes, and we have local stakeholder support for the project, and I think it bodes well for the ability to find those funds.
Can you tell the group you're planning on going up to Sacramento? I heard, you and Paul, what is the purpose? Is it related to this project?
I don't have any specific plans to go to Sacramento with Paul.
No, I'm going on a different matter.
Oh.
Way different.
But I'm happy to help anybody that's doing work at and around the sea that improves the life and quality of the community.
Mike, I'm asking about the water data, so we tested them. Can you share the actual test reports on the water quality? I know we have the Carroll County Environmental Health here as well. We'd like to be able to dig into that a little bit more. I know you're telling us that it's saline practice, but just want to make sure that we can check it and see where we have other resources in the valley and comparison, just to build our own data.
Sure.
It's in the report, right? That's after from Paul, when you want to do, yeah, it's in there. So, yeah, I mean, if you want, I can get your email. I can send you a link. It's a big report.
I just want to know before we get off that clock on the wall. It's the only time it'll be.
Mr. President, can you, when you're providing the hydrology part of this study, is there a way we can have that presented to Supervisor Kelly, because he's been working on the CEQA project, and I think the only limiting step was the hydrology study to complete the CEQA. So we'd like to see if we can at least get that part of it done. I don't know if any specific extra funds need to be provided.
So that sequel was based on the original idea of fill the channels. Now we're talking about design, such as the one that Tom has suggested, which is going to require a new sort of fresh look at what the design of the project would be, and then sequel. So that's why it's going to just starting a little bit over, but we still have the path go forward. That's it. The data that you got this enough to do both.
And the county's been working on staff with us.
Right. And to your question, Brian, they did a very thorough analysis of what came up with the well and also of various subset borings. They tested heavy metals, they tested pesticides, they tested organics, they tested a wide range of them. And with the exception of it being a little too salty to drink, it mostly passes. It's pretty darn clean. There's no toxicity for it. I did look at everything, and I was impressed with it.
There's two reasons I'm asking. One, be able to have pretty positive, to not have the regional water quality boards, coming in and saying something different. The other is to identify vegetation that could actually benefit that water.
Yeah, about 3,000, roughly, and it is similar to Iowa Bridge. So, it's clean.
Yeah, and all of that's in the report, I have to wait until Paul Patrick, so I can send it out. As soon as they give me the word, I'll offer it if anybody wants it, but,
Send it out.
okay.
Send it out. All right, that's right.
Any other questions before we wrap up here? So I just want to say thank you to you all for attending.
I think
This was-
Joe had a question.
Oh, Joe.
What's going on?
I just wanted to get the team's, I guess, kind of high level takeaway of some of the estimates that are here. Because obviously, being here from the state, Patrick's heard me talk about this a lot, but climate bond just passed, there's funding out there, it is competitive. It often requires proposals that have some level of momentum or kind of details ascertained, and expressed in a concept. It seems like some of the cost pieces here, looking at alternative, 3, 4, they're kind of reliant on the borrow material being present. And if it's not present, then we're kind of looking at a potential exponential increase, right? So I just, I'm curious to get a sense from folks on just as the folks who are kind of looking at this really closely from a technical level, what's your kind of ballpark here if you're trying to park some level of uncertainty here, but still, give folks just kind of a rough estimate of the magnitude of capital that it would cost to, advance some sort of concept here.
Oh, okay. You want to start? Sure.
So a better cost estimate would come after you have some design plans, and we don't have that. We're working off of concepts. So there's a lot of things that are assumed in here. So I'd throw in a 30% contingency on top of this. We have some ideas, but there's some things that we need to focus on a little bit more to get the numbers better. I think the numbers that we came up with the cost estimate was to help decide, hey, is this method going to be 10 times as much, or is it going to be 2 times as much to do a liner than just fill the ponds back in? From our numbers, fill the ponds back in with dirt was $8 million. And to do a clay liner, I think we're looking at $11 or $12 million. So gives you a ballpark of what you're looking at. And so it might be reasonable to do some of these things. And when you talk about, looking at the borrow source, yeah, but that's why we looked at an HDPE liner. That way it wouldn't matter what the soil is in the borrow source. We could use whatever they have as long as it's not razor blades and rocks. So I think, hopefully that answers.
Speak loud.
Paul would say this, I'm gonna say it for him. He and I have real skepticism about relying on that clay liner being there. Right, so we even talked about pulling that option out of the presentation. But I think it's worthy of discussion. There are a lot of things that we just don't know. And based on what we think, it's a reasonable representation of what might be. It's just we need to decide conceptually and directionally where we're going to go with the project, and then start really putting a design pencil to paper and figure out what the real costs are. But I think that this gives us an understanding of what the scope and scale of this
effort will require.
I'll just point out that there are a couple of alternatives here that do not rely on plain or meaning high quality fill material, and they would be alternative to B, HDPE plastic liner across all 5 channels and the connecting channel at the high cost of almost $1 million. And we will let the experts evaluate alternatives 5A and 5B, but those also require no fill material other than the berm itself. And that comes in at, I think 5A is 5.7 million and 5B is 5 million. But you guys are gonna probably find some ways to add some cost to that.
I would just add to Steve, he's absolutely right. We'll know more when we do the design, and then we can actually work toward a real construction estimate. But I'd also like to point out that the community has been waiting for this project for an awfully long time. If you look at the construction costs of what it was 5 years ago, compared to what it is now, compared to what it could be 5 years from now, it is a losing battle. It's not going down, it's just going up. And so one of the things that you'll see at the end of this presentation is we talked about having more meetings to discuss with the community the design and moving forward with that, with the idea of creating a design that allows us to go and permit and get a shovel-ready project so that we can actually start construction on a project sooner as opposed to later. And so that's why when I started the meeting, I said that this is just the first meeting of more discussions that are required. And Tom has added something all brand new, which we haven't even had a chance to talk about. So I thank you for that, Tom. We're very grateful because that is exactly, you've short-circuited, you've made it shorter now by coming up with a very substantive proposal that needs to be reviewed, and we have the experts to review that. So I don't have any magic words on when it comes to construction, other than it continues to go up, and up, and the money gets harder and harder to obtain. So we have to balance those things.
Yeah, I have a question for Mr. Shea. Can we get an idea of what we would need from the state in order to obtain funds from the Proposition 4 bond issue, which seems like this project has multiple components that would be, check the boxes, of that proposition. But we would like you to tell us how we can move that forward in the right manner to get that money in from that proposition.
Yep, thank you for the question, and that's exactly where my head has been at. I mean, I appreciate all of the work that folks here and the team have done to advance these different concepts and put, as best they can, price tags. And I think there's been a lot of really incredible work from the folks at the technical level to try to just, again, shed more light here. And frankly, the reason that I'm here is because I want to get this done. Like, I appreciate all the work that folks at the community have done to get this into the SSMP. Ultimately, our state charge is 30,000 acres. I think this is about 30 acres. But what I tell folks, especially my colleagues who have, money or will have money with the climate bond, is like, this is one of those projects that might not show up on the stat sheet of the SSMP in terms of like a quantum leap for us towards the 30,000 acres, but it's where folks live around the sea. So it needs to be weighed with the utmost priority because of that. And so again, that's why I made the trip out here and why I'm glad we've had such a great discussion. As it relates to the funding that's in the climate bond, there's a lot of nooks and crannies that I think we can look, but at a high level, funding just got approved by the legislature like 2 weeks ago. And at this point, there's a lot of new programs that are going to be stood up from the department levels who put the funding out. So typically, you're gonna see those folks drafting guidelines, and if they're really fast, they'll get those draft guidelines out for their new programs like by January. Some of that funding is going in existing programs, which might already have guidelines that maybe aren't gonna be changed that much, and those are the ones that, come in the new year, we might actually see notice of funding availabilities accepting, Prop 4 money. Broadly speaking, you can go online to the Resources Agency's website to see how the breakdown of the $10 billion from the climate bond is currently being allocated. I think the budget that just got passed made about 2.6 billion available. There's so many different programs, so I'm not gonna, go through them here, but broadly, there's, I think, like 6 or 7 buckets, right? And one of those buckets is extreme heat. And I think this region, perhaps more than any other, has a very good case to make for that. Most of that money is at the Office of Planning and Research. As far as I've checked, I think some of that's going to be in new programs, but I actually sent an email on Friday to some of my colleagues asking, like, hey, what's the latest with this and when can we sit down? So I'm waiting to hear back from OPR on that. And as soon as I get more info, I'll make sure that these folks are tracking it, because I think the extreme heat line item is a good one. There's another one that I'm interested to understand in greater detail what we might be able to do if we're looking at potentially doing some vegetation enhancement. Like there's an urban forestry program that's run out of CNRA, and then there's a kind of a partner program that's run out of the fire department. But urban forestry is a bit of a misnomer because what they actually have historically funded is trees. And so, planting trees, and I think we would have to take a closer look at the soil and how you would irrigate that. But I think that's another type of refugia that might be helpful in this area. In terms of some of the other programs, I think you're hearing me ask more questions about concepts. I know that, we're kind of at a very early stage of putting the finer details on this thing, but I'm asking more on the concept because that I think helps inform the different programs that we could go after. But I think, we can continue, I'm going to continue to look through the bond language, the guidelines, the new programs, the existing ones, and continue to kind of think on it. But I definitely would appreciate every last person in here who wants to help with that, and including the folks online who have ideas, because I think there's the inputs here to do something really special. It's going to take a commitment to honing in on these kind of finer points of detail to figure out what exactly is the right fit, and from there, get the permitting done, apply, go through all of that, and hopefully come out successful on the other end.
Thank you. I think there's 1 or 2 more questions online. Yep.
I'll just quickly, I know they sent over the questions, so there's 3 of them. You gentlemen, has there been any studies in relation to this project that have touched on habitat restoration? What is the water quality goal, and what fish life might be sustainable?
No, the biology part has not been considered at all. We need to know what option we go with, do the design, and then, that would be part of the design process, is what kind of habitat restoration you're gonna do. Yes, there are brackish water and fish that thrive in that kind of water. Plants as well, but I don't know if when we spoke before, you probably, if you put in the liner in, you have little plants going there. That probably turn the one around. Was there a question that water quality?
It was just touching base on habitat restoration, and then what fish life might be sustainable.
There's a number of fish But, you know, get fish and, you know, probably affect birds, fish and things like that, so. And again, that would all be part of the design process, yeah.
There are a range of fish that can survive just fine in the water that's available. As you know, that it's brackish water from the well, but because of the fact that if you use that brackish water, and if you do align them with clay or plastic, you're gonna have a problem with plants that thrive in that environment, like tamarisk and cattails, roots, tamarisk, but roots, even through plastic. And a large pond was one we played in, and they had water supply, they wanted, I assume, to happen. And they had cattails, their roots through the clay. And they lost the water, the kitchen, so that is a realistic concern. We discussed this a little bit, and I think we need to seriously think about this. In order to control, one, the plants that would grow in the water and destroy the liner, and two, the fact that desert shores is largely free of rampant mosquitoes because the water here is hypersaline, so the sea itself. So I would suggest that you take the page, the playbook, species conservation, and blend a little salt and seawater into that well water and design it for a marine environment. And we know that if you do that blend, you've got everything from native desert buckfish to Mozambique tilapia that used to thrive by the millions in the Salton Sea and used to thrive by the thousands in the desert shores channels themselves, used it as a breeding area. You can see the evidence of it in the fish nests all along the sides. So there's definitely a range of species that used to thrive in the Salton Sea several years ago that would easily be introduced into the channels, and it would attract the birds. I noticed a couple of weeks ago that we're starting to get some pelicans back in the one of the species conservation habitat ponds. We had several dozen pelicans in one of those ponds a few days in a row. And I think they would come back to the shores as well if you had that kind of water quality in there. And also just commenting on Joe Shake's comment about where you go for funds. I think urban forest is not out of consideration. I stopped by my trees out at the end of the creek before I came over here to make sure irrigation system is running, and it is, and it's been running great for almost a year now, automatically every day. That's using Coachella Valley Water District water, and it's a little price. We were paying them about we've been paying about $140, $130 a month for that, for a pretty small, 2 lots. If you did it on a larger scale, it is not crazy expensive to take brackish water and just take a portion of it and take some of the salt in the RO system and use that as your tree water source. That doesn't cost that much. In fact, you could probably take it down and with even the filtration system, which has a lot more flow through for the money to grow trees. In many places around the shores, they never qualify for urban forest.
All right. Well, thank you, Tom. And thank all of you for your participation this evening. I think this was most helpful. And really appreciate all your great comments and questions. And we'll be getting in touch about our next session and moving forward in the process of all the funding provided us. I don't know. We'll take a look at it. And we didn't have a chance to look at it thoroughly today, Ron, but we'll take a look at it and get back to you. So, all right. Well, thank you very much. And I hope you have a safe ride. Thank you. I can share.